you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, it's Mr. T, and today we have a tutorial on systems of equations. This is the second part of tutorials on systems of equation, and we're going to be discussing solving systems of equations by graphing. And in particular, we're going to be using a graphing calculator. We can solve systems of equations by graphing when we have a system of two equations, so only two variables. If we had a system of three equations and three variables, we would have to use other techniques. Solutions are found where the two functions intersect. In our systems, we could have systems where both equations are linear, or we could have ones where the equations are nonlinear, say quadratics or other shapes. We're going to use the graphing calculator to accurately find the intersections. If you try to graph them by hand on a piece of paper and find the intersections, you can only get a fairly rough estimate of what the intersection would be. So our procedure, we have to, because of the way the graphing calculator works, we have to solve each equation for y. We need to set it as y equals. If you're using other graphing utilities like Desmos, which is on the internet, it will allow you to enter the equations in standard form, so we could skip this first step. But we're going to focus on our graphing calculator. So we're going to algebraically solve each equation to get the y by itself. We're going to enter the first equation into the y1 on the graphing calculator and the second function into y2. We'll initially graph it by pressing the Zoom 6 button. We've done these in other tests. That resets our window to a standard window called Z standard. It essentially has 10 units in each direction on the coordinate plane. We need to be able to see all of the intersections in the problem, so we may have to adjust the window in order to see our intersections. Once we see the intersections, we will be using the calc function of the graphing calculator to find the intersections. So we'll be pressing the second calc button. You'll move the cursor near the intersection, pressing only the left and right arrow keys to move the cursor, and then we will press enter 3 times. And at the bottom of the screen will be the x and y coordinates of the intersection. We'll record those. Now you need to do that process, here, these steps, you need to do it for each of the intersections. So we'll be demonstrating this with the graphing calculator in a few seconds, and you'll see these steps. Just remember, if we are adjusting our window, if we want to see higher, so on our coordinate plane, so when we do the Z standard, we're going to be going up to 10 on each direction and -10 on the left and down. So if we believe our intersection is up here, we need to increase Y max. If we think we need to see it down below the graph, we want to change Y min and make it larger negative. And right and left will be X max and X min. So you just have to kind of guess where you think the intersection is and make some adjustments until you find them. So let's look at some examples. Our first examples are all linear equations. So if we take our first first equation here and solve it for y, I could add the y to the other side and add the 5. So I've got 3x plus 5 equals y. So again, I added y to get that to the other side, and I added 5 to get that over here. Now we can take the second equation. I need to subtract the 4x, so I have 2y equals -4x plus 38. And now we have to divide everything by 2. And we have our second equation, which is -2x plus 19. So let's bring our graphing calculator over and power it on. So to enter the equations, we're going to press y equals. You can delete any equations that are there. So our first equation here was 3x plus 5. And our second equation was negative 2x. Remember to use the negative button to get the negative 2 on the x, plus 19. And we now want to graph pressing zoom and 6, the z standard. So that's our y1. It graphs that first, then the y2. Now we don't see our intersection, but we could guess that the intersection is up higher. So let's change the window. So press the window button here. And we want to see higher, so we want to set y max to a bigger number. Let's try 15. Press graph. Okay, we can now see the intersection. So now we're ready to use the intersect function. So we're going to get this calc menu. So we need to press second, calc, and we want intersect item 5. And now I am going to use the right arrow key to move that near the intersection. You just have to get it close. You don't have to get it right on it necessarily. And let's press enter 3 times. 1, 2, 3. And now it says intersection. So our answer for this system is 2.8, 13.4. So if we solve this algebraically like in the first tutorial, we would be getting that answer. So let's look at example 2. So let's first solve each of our equations for y. So I'm going to subtract the 2x. And then divide by negative 4. And I've got y equals positive 0.5 x plus 5. And now let's do the other one. Subtract the 3x. Divide by our negative 6. And we have y equals 0.5x minus 2. Now you might know by looking at these that what kind of lines are these when we have the same slope. Okay, they're parallel lines, but let's just assume we didn't observe that. We were just kind of in crank mode here. So let's enter our functions. I'm clearing the calculator. All right, I have the functions entered into the calculator, so let's press graph. Remember to reset our window. We're going to press zoom 6. And as we guessed, because they have the same slope, we have parallel lines. So where do parallel lines cross? Do we need to see further over this way or this way? And of course you know the answer is no, because parallel lines never cross. So for this one we have no solution. Now, given that we had to use the graphing calculator and solve this for y, you really wouldn't be using the graphing calculator to discover that there's no solution on this. However, if we had a graphing utility where we could enter equations like this, you might not know that they're parallel, and we would see by the graph that the parallel lines have no solution. So let's look at our last linear system here. We have this equation. So for this one, we're going to subtract the 14x, and divide by 7. And we get y equals negative 2x plus 1. Now notice these are the same equations. So everything that makes this one true is also going to make this one true. So we know just by looking at this that it's all real solutions, or actually we've been calling that here infinitely many solutions. And if we enter it in the graphing calculator, let me just do that. When we graph it, whoops, I hit the wrong button here. I hit trace, but we'll see. Now we only saw one graph. So we might play around with the window saying where the other function go. If we looked in the table, we can see that in y1 and y2 for every x value, the y values are the same. So now let's look at our examples where we have nonlinear systems. So again, our first step is to get the y by itself. For this first equation, we're going to have y equals negative 2x plus 3. On this one, we can move the y over here to the other side, and we get this, which you should recognize as being a parabola. So let me enter these in the calculator. And let's graph it. Let's press zoom 6. That's our linear function. Now we're only seeing part of our parabola here. So remember, the parabola is probably coming down and going up. So there's probably two intersections. So we need to see further down. So let's let the window go down, let's say to, let's try negative 20, see if that's far enough. And we may need to see further down still and more to the right. So let's check with the window here. Let's go a little bit further to right. So let's go over to 15 and let's go further down. So let's just go big. Let's go negative 50. So now we can see we have two intersections. So when we have two intersections, remember we've got to do this process of the second calc, intersect, which is number 5, get it close to one of the intersections, and now we have to press enter 3 times. Now I hit it 3 times, but I didn't. Make sure that you've got the word intersection here. So our first solution is, and we'll just round this to say 2 decimal places, negative 0.57, comma 4.14. And now that was this solution. Now we need to find our second solution. So we have to repeat second calc intersect. Now we need to move the cursor over towards that second intersection, say right around there. Now we want to hit enter 3 times. So it says intersection, so our second solution is 10.57 and negative 18.14. So we have two solutions to this nonlinear system. Now when we look at our last one here, we've got x squared, well, let's see, we want to get the y squared by itself, so let me undo what I did there. That wasn't helpful. So we want to get the y squared, the y by itself, so we first have to get the y squared by itself. So it's going to be 18 when I add that minus x squared. And now we've got to take the square root to get the y by itself. So remember, when you take a square root, we have both a positive and a negative square root. So we're going to have to turn this into two functions. Y equals positive the square root of 18 minus x squared, and y equals negative square root of 18 minus x squared. And this is going to be our y1. Now we're going to do these into y2 two separate times. Now if we solve this as I started to do, x squared plus 18, plus y squared equals 18. You may remember that's the equation of a circle. So that's not really a function, and the graphing calculator only deals with functions. So I'm going to enter this into y1 and this into y2, and let's look at what we've got. So I'm just going to enter the positive square root here. So let me go enter that stuff. So I've got the functions entered, so let's press graph. Let's do zoom 6 to get our window back. And we see we have half of the circle. Our other half will be down here. Now it doesn't shape a circle because the x and y axis here scales aren't the same. So it doesn't quite look like a circle, but that would be a circle. So we're seeing the top half of the circle. And on the top half of the circle we have one intersection. So let's find that intersection. So second calc 5, move it close to the intersection, press enter 3 times. And we get our first solution is at negative 0.6 and 4.2. So now to find the second intersection, it must be down here in the bottom half, so we have to change our y2. Instead of being this function, we now want it to be this function to get the bottom half. So it's the same thing except a minus in front, so I'm going to edit my y1. So I'm going to move my cursor down here, and I'm going to press second insert here to add that negative sign. So now we've got negative the square root, so let's press graph now. And notice that gives us our bottom half of our circle, so now we can find this second intersection. So we've got second calc 5, and move it near that intersection, and press enter, enter, enter. So our second solution is at 3, negative 3. So these are our two solutions to this system of equations. Now, I did it in the way that I think is simplest, is to enter each of these separately and find the intersections. We could have entered, I'm going to enter into y3 the top part of this function. So let me enter here, second square root 18 minus x squared, so that we see the entire circle. But there's some issues with using the calculation function of finding these intersections with selecting functions and using this arrow to change functions. So I think it's going to be easier for you if you do the way I did first. So just put in two functions at a time, the linear function in one semicircle, then the linear function and the other semicircle. So good luck. The graphing calculator can make it very easy to solve systems of two equations, and good luck and see you around.
Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready?